Another way to activate alcohols is SOCl2. So PCl3 doesn't work very well. So PCl3 doesn't work very well. So we have a different reagent to use, SOCl2, if we want to add a chlorine. So PBr3, PI3 work, but PCl3 doesn't work. So if we want to add a chlorine, we needed a different reagent. So we used just kind of how we did. We need a different reagent for chlorine for that Lucas reagent, the zinc Cl2. If we just want to add a chlorine more modern way, we'd use SOCl2. So SOCl2, and you can see by looking at the product, there's inversion. So that should make you think, well, the alcohol was wedged, and the thing we substituted on here is hatched. That means there must be an SN2 reaction going on here, right? SN2. So it's a secondary alcohol. And we're thinking SN2 reaction for sure. So the mechanism must involve that. First step, though, in every mechanism for these activation of alcohols is, right, using the alcohol alone pairs as a nucleophile. The sulfur is pretty electron deficient. Looks like a carbonyl almost. So we add in, we do an addition reaction. Do an addition reaction. We create a tetrahedral intermediate, very similar to when we had Grignards or organolithiums or acetylide, the alkynes with a negative charge, or a hydride, an H- attacking a carbonyl. Same type of thing. sp2 hybridized. Now it's sp3. We have a tetrahedral intermediate. Every time you make a tetrahedral intermediate, you ask yourselves, is there a good leaving group? Is there a good leaving group here? What could be a good leaving group? The chlorine. Chlorine could, right? Cl- would be stable. That's why you're asking, what is there something stable on its own? Cl- would be stable. Somebody might say, well, why not kick this out? You certainly could, but that's just going back here. So, right, that's gonna it's not productive moving forward. This reaction is actually driven. Don't forget this. We make SOCl2 here, and that's gonna become important. Remember, that's a gas. So that'll help shift equilibrium. If a gas is one of your products, it goes out of solution. There's no going back to start materials. Okay. Back to our tetrahedral intermediate. The electrons come down, kick out one of these chlorines. Plus charge to oxygen, and a Cl-. So what have we done? It just took 2 steps here. So we did what was our first step? We did an addition reaction, right? We added something in. And the second step, what kind of reaction is this? It's an elimination. We're forming a pi bond. So this is that addition elimination mechanism we've learned at the beginning of this chapter. Now we have our alcohol, good and activated, good leaving group on there. Let's have the chlorine come back around and do that SN2 reaction. Kick out the good leaving group. We've inverted the stereochemistry, right? We did an SN2 reaction. The other byproduct. Oh, I screwed up. We didn't use the pyridine. We're going to do that in a second. Oh, I forgot about the pyridine. Now I'm going to use it. So we're done with our product, right? That goes to here. So we're just good there. Then how are we going to make this SOCl2? This is where the pyridine comes in. Where the pyridine comes in to help out. Or the pyridine. So the pyridine either could come in now, or the pyridine could have came in here. It doesn't really matter when the pyridine comes in. Either way, in our book, the pyridine takes the H here. But you can take the pyridine can take the H here too. It gets you to the same place. So it's okay. Pyridine acts as a base. So the pyridine is going to take this H. These 2 electrons are going to go between the O and the Cl, form a pi bond. and this sulfur and chlorine bond is going to break and kick out a Cl minus, and that's the other byproduct here. And the pyridine with the H on it. So we could have done this, right? The pyridine could have came here and taken the H, that's fine. Or you could wait until it kicks it out and then take the H here and do all these steps to make the SOCl2 form. The key here is this is a gas that shifts equilibrium, that helps drive this reaction forward, and you get our SN2 reaction. Made a mistake. I did not balance my charges. There should not be a plus sign there. My mistake. Right, it's neutral. So once this gets kicked off, there should be no plus charge on that oxygen. Right, oxygen wants 2 bonds. That was my fault. But this could deprotonate that, take that H, driving force again, generating this gas and then salt. But the pyridine, like I said, could work. It could take the H here, or it could take the H here. Either way, it's fine.